Hello. This will be a demonstration of Proposition 23 from Book 9 of Euclid's Elements, which says that the sum of an odd number of odd numbers is also odd. We're given three numbers, A, B, B, C, and C, D, all of which are odd numbers, and the multitude of which, in this case 3, is odd, because 3 is an odd number. And what we want to prove is that their sum, which is the number AD, is also an odd number. We're going to begin by subtracting a unit from the number CD. So we're going to have the number CD minus the unit DE. That's going to make the number CE. And because we know that the number CD is an odd number, and we know from the definition of odd numbers, which is definition 7.7, that an odd number is always one away from an even number. If therefore we subtract a unit from an odd number, the remainder will be an even number, so that because we have subtracted the unit DE from the odd number CD, the remaining number CE will be an even number. But we also know that the number AC is an even number. We know this because it is the sum of the two numbers AB and BC, each of which is an odd number, and their multitude, in this case 2, is even. And Proposition 9.22 tells us that the sum of an even number of odd numbers is also even, so that the sum of the two odd numbers AB and BC, which is the number AC, is an even number. And so if we add the two even numbers AC and CE together, we will therefore get another even number according to Proposition 9.21. That proposition tells us that the sum of any number of even numbers is also even, so that if we add the two even numbers, AC and CE together, the whole AE will be an even number. So then, if we add the unit ED back into it, we get the whole AD. And we know from the definition of an odd number that it is always one off from an even number. And so if you add a unit onto an even number, you'll get an odd number. So if we add the unit ED onto the even number AE, the sum, the whole, which is the number AD, will therefore be an odd number. And this is what we set out to prove. We set out to prove that AD is an odd number. So having proven that, we are therefore done with the proposition. Therefore, etc., QED. So unlike even numbers, where it doesn't matter how many of them you add together, the sum will always be an even number. With odd numbers, you actually have to take care to number how many odd numbers you're adding together. And if that sum is even, then the sum you'll get, or if the multitude is even, I should say, then the sum you'll get of the odd numbers will be even as well. But if the multitude of the odd numbers is also odd, then the sum will be odd, as we've just shown. An example of what this proposition would look like is if we have the three odd numbers, 3, 5, and 7. Their sum is number 15. Now, I hope you can agree that our three numbers, 3, 5, and 7, all of those are odd numbers. And furthermore, we have an odd number of odd numbers. We have three odd numbers, and 3, again, is an odd number. So what this proposition is going to tell us is that their sum, which in this case is the number 15, is an odd number. How Euclid goes about proving this is he takes away 1 from 7, or he takes away 1 from the last even, or the last odd number. So what we'll have here is we'll have 3 plus 5 plus 6 plus 1, because remember we took that unit away. That's still going to equal 15. Now, the number 6 is going to always be an even number because we got it by taking a unit away from an odd number. And we know that an odd number is always 1 away from an even number. So if we subtract 1 from an odd number, we'll get an even number. So this last number here in this sum will always be an even number. We also know that the sum of these numbers will also be an even number as well, because the multitude of these two odd numbers, in this case 2, because we have 2 of them, that's an even number. So that's going to tell us that this sum right here is even. Because we learned in proposition 9.22 that the sum of an even number of odd numbers is also even. So 3 plus 5, that'll be an even number. And we know that this will also be an even number. We just mentioned that. So this whole sum of 3 plus 5 plus 6 will therefore also be an even number, because we know from proposition 9.21 that the sum of even numbers is always an even number. So if we add these two even numbers together, we'll get another even number. In this case, that'll be the number 14. And we'll be adding the unit back into it to get our original sum of 15. Which then tells us that 15 is an odd number, because we add 1 onto an even number to get it. And we know that odd numbers are always 1 away from an even number. So in order to get 15, if we have to add 1 to an even number, 15 is therefore an odd number. So we say that this proposition holds. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 9.24.